Welcome back. So let's look at an exercise now. For so here we have a function f whose graph is given, and we want to find all values of x where f is discontinuous. And then we want to make sure we understand why that's the case. So if this is the graph of the function f. So you should pause and take a few seconds, think about this question, and then answer this question, and after that come back and then you can match your answers with mine. Okay, so I hope you paused and thought about it. So let's first look at the point x is equal to -3. So what do we see here? Well, what we see here is that the limit of the function is at -3. The limit of the function is 3, but the function is undefined there. So f is undefined there. So f is discontinuous there. At -1, what do we see? Well, at -1, we see that f is defined, right? F of -1 is equal to 1. So f is defined at -1. However, what's the limit? Well, at the two-sided limit at -1 doesn't exist because the right-hand limit at -1 is 2. The left-hand limit at -1 is 1. So they are not the same. So therefore, it is the limit at -1 does not exist. So it's discontinuous there. And then we have the point x is equal to 2. And there we have the same issue as we had at the point -1. So there we have that the limit, no, sorry. So at the point 1, notice that f is defined. So f of 2 is 3. F of 2 is 3. However, what is the limit at 2? Well, the limit at 2 is 5. The limit at 2, if you approach 2 from the left, you're approaching 5. If you approach 2 from the right, you also approach 5. So the limit at 2 is 5. The value of the function at 2 is 3. So since the limit at 2 isn't the same as the value of the function at 2, it is still discontinuous at 2. So what do we see then? We see that this function is discontinuous at -3, -1, and at 2. All right, let's look at the function f of x is equal to x minus 2 over the absolute value of x minus 2. So what we want to know is whether this function is continuous at x is equal to 2. So notice that when x is bigger than 2, if x is bigger than 2, inside the absolute value here, x minus 2 would be positive in this case. So if x minus 2 is already positive, then you don't need to put the absolute value signs. So then I get x minus 2 over x minus 2 here, which would be equal to 1. On the other hand, if x is less than 2, in that case, x minus 2 would be negative. So if x minus 2 is negative, then negative x minus 2 is positive. So I can get rid of the absolute value signs by putting a negative in this case in front of x minus 2. So in this case, I get -1 to be the value of f. So what do we get? We get that f is 1 in the first case when x is bigger than 2, and when x is less than 2, the value of the function is -1. So And so also notice that the function f is undefined at 2, because if you, when x is 2, you get a 0 in the denominator. So we see that f is discontinuous at x is equal to 2, and as a result we can say that f is but otherwise if we compute the if we look at the function, it will be continuous everywhere else. It will be continuous on the set of all real numbers except 2. So again, this symbol means that this is the set of all real numbers without 2. So you might say, why would the function be continuous everywhere else except 2? Well, because if you take the limit of the function at any other value of x, the limit would be found by simply plugging in x, and so that's the same as the value of the function. Another way of looking at it is that, if you look at the graph of f, it's going to when x is bigger than 2, it'll be a horizontal line at height 1, and when x is less than 2, it'll be a horizontal line at -1. So from the graph you can also check that this function is continuous everywhere except 2. So that's the end of my the exercise that are here, and I will stop with this exercise. In the next video we will be looking at some of the continuity properties.